like terms in algebra. We'll solve this step by step by adding these three expressions: 2x plus 8y, 2 minus 8x minus 6c, and 11x minus 2y. The key to combining like terms is to identify terms with the same variables. Let's organize our terms by grouping them based on their variables. We'll start by listing all terms with x, then y, then z, and finally any constant terms. Let's identify all the terms with x. From the first expression, we have positive 2x. From the second expression, we have negative 8x. And from the third expression, we have positive 11x. Now, let's look at the y terms. From the first expression, we have positive 8y. And from the third expression, we have negative 2y. For z terms, we only have negative 6c from the second expression. And finally, we have the constant term positive 2 from the second expression. Now, let's combine the like terms. First, let's add all the x terms. Positive 2x plus negative 8x plus positive 11x equals positive 5x. Next, let's add the y terms. Positive 8y plus negative 2y equals positive 6y. The z term remains negative 6c, since there are no other z terms to combine it with, and the constant term remains positive 2. Now we can write our final answer by combining all these terms: 5x plus 6, y minus 6c plus 2. And that's our simplified expression. Remember, when combining like terms, always look for terms with the same variables raised to the same powers, and don't forget about constant terms. A percentage problem. A coolie deposits 150 rupees per month, which is 15% of his monthly income. We need to find his total monthly income. Let's first identify what information we have. We know that the deposit amount is 150 rupees, and this represents 15% of the total income. Let's visualize this with a diagram. This rectangle represents the total monthly income. The shaded portion represents the deposit amount, which is 15% of the total. To find the total income, let's think about this step by step. If 150 rupees is 15% of the income, we can find 1% by dividing 150 by 15. Then, to get 100% or the total income, we multiply that result by 100. Let's solve this step by step. First, let's divide 150 by 15. 150 divided by 15 equals 10. So 1% of the income is 10 rupees. Now, to find 100%, we multiply 10 by 100. Therefore, the total monthly income is 1,000 rupees. Let's verify our answer. 15% of 1,000 rupees is indeed 150 rupees, which matches our original deposit amount. To summarize, when solving percentage problems, remember these steps. First, identify what percentage the given amount represents. Then find what 1% equals by dividing. Finally, multiply by 100 to get the total amount. Let's solve a problem about finding the area of a square. We're given that the side length of the square is 2/3 a cubed b cubed c cubed, and we need to find its area. Let's visualize this. Here's our square. The side length of the square is 2/3 a cubed b cubed c cubed. And remember, to find the area of a square, we multiply the side length by itself. So to find the area, we need to multiply 2/3 a cubed b cubed c cubed times 2/3 a cubed b cubed c cubed. Let's solve this step by step. First, let's multiply the numerical coefficients. 2/3 times 2/3 equals 4/9. Next, we'll multiply the variables. When we multiply variables with exponents, we add the exponents. So a cubed times a cubed gives us a to the 6th. Similarly, b cubed times b cubed gives us b to the 6th, and c cubed times c cubed gives us c to the 6th. Let's visualize what this means. The area of our square is 4/9 times a to the 6th times b to the 6th times c to the 6th square units. Let's summarize what we did. First, we recognized that to find the area of a square, we need to multiply the side length by itself. Then, we multiply the fractions. 2/3 times 2/3 equals 4/9. Finally, we added the exponents of like variables. 3 plus 3 equals 6 for each variable. Therefore, the area of the square is 4/9 a to the 6th b to the 6th c to the 6th square units. Let's solve a profit and discount problem. Jasmine allows a 4% discount on the price of her goods and still earns a profit of 20%. What is the cost price of a shirt marked at 850 rupees? Let's visualize this problem with a diagram. First, we have the marked price of 850 rupees. From this, a 4% discount is given to the customer. This gives us the actual selling price. And we know that this selling price includes a 20% profit over the cost price, which is what we're trying to find. Let's solve this step by step. First, let's calculate the selling price after the 4% discount. To find this, we multiply the marked price by 96%, or 0.96, since 4% is being subtracted. So 850 times 0.96 equals 816 rupees. Now, we know that this selling price of 816 rupees includes a 20% profit over the cost price. To find the cost price, we need to divide the selling price by 1.2, since the selling price is 120% of the cost price. So 816 divided by 1.2 equals 680 rupees. Let's verify our answer. If we add 20% profit to our cost price of 680 rupees, we get 816 rupees as the selling price. And when we add this 4% discount to get back to the marked price, we indeed get 850 rupees. To summarize, we first calculated the selling price by applying the 4% discount to the marked price. Then, we found the cost price by removing the 20% profit from the selling price. Our verification shows that this answer is correct. Let's solve this algebra problem step by step. We need to simplify and evaluate the following expression when x equals -2 and y equals 1. Let's break this down into parts. First, we have the product of two factors x minus 8 and x squared plus 9y. Then we're adding 21x to the 10th power. Let's first distribute the terms in part 1. When we multiply x minus 8 by x squared plus 9y, we get x cubed plus 9xy minus 8x squared minus 72y. Now we can write our complete expression. It's x cubed plus 9xy minus 8x squared minus 72y plus 21x to the 10th power. Now let's substitute x equals -2 and y equals 1 into our expression. First, let's substitute x equals -2. This gives us -8 for x cubed, -18 for 9xy, -32 for -8x squared, -72 for -72y, and for 21x to the 10th power, we get 21 times -2 to the 10th power. Let's evaluate each term separately. -2 cubed is -8. 9 times -2 times 1 is -18. -8 times 4 is -32. -72 times 1 is -72. And finally, -2 to the 10th power is 1024, and 21 times 1024 is 21,504. Now we can add all these terms together. -8 plus -18 plus -32 plus -72 plus 21,504 equals 21,374. Therefore, when we evaluate the expression at x equals -2 and y equals 1, we get 21,374. Let's review what we did. First, we distributed the terms in the first part. Then we combined like terms. Next, we substituted x equals -2 and y equals 1. Finally, we evaluated each term and added them together to get our answer. Welcome! Today we'll learn how to subtract algebraic expressions with multiple variables. Let's solve this step by step. Let's start by writing out our problem clearly. We have the first expression x minus 3y plus 2z, plus the second expression, -4x plus 9y minus 11z. And we need to subtract 3x minus 4y minus 7z from their sum. Let's first find the sum of the first two expressions. When we add these together, we combine like terms. Looking at the x terms, we have x plus -4x, which gives us -3x. For the y terms, we have -3y plus 9y, giving us +6y. And for the z terms, we have 2z plus -11z, giving us -9z. Now we have simplified the sum to -3x plus 6y minus 9z. From this, we need to subtract 3x minus 4y minus 7z. Remember, when we subtract an expression, we can distribute the negative sign to each term inside the parentheses. Let's combine like terms one final time. For x terms, we have -3x plus -3x, which gives us -6x. For y terms, we have 6y plus 4y, giving us positive 10y. And for z terms, we have negative 9z plus 7z, giving us negative 2z. Therefore, our final answer is negative 6x plus 10y minus 2z. Let's verify this is correct by checking our work. Let's review the key steps we used to solve this problem. First, we added the first two expressions by combining like terms. Then, we distributed the negative sign when subtracting the third expression. Finally, we combined like terms one more time to get our answer. Remember, when working with algebraic expressions, always keep track of your signs and combine like terms carefully. Thank you for watching. Practice these steps with different expressions to become more comfortable with algebraic subtraction.